Okay, today we're going to talk about empirical formula. What is empirical formula? How do we determine the empirical formula of a compound? And also just give you an introduction to the next lab that will be due after the fall break. I do not expect you to have to work on this lab during fall break, but I do want to go ahead and introduce that to you so you will be ready to have that completed the week after we return from the break. So first of all, what is an empirical formula? It is the formula of a compound that expresses the smallest whole number ratio of the atoms present in the molecule. Ionic formulas will always be empirical formulas. When I say the smallest whole number ratio, kind of like in reducing fractions, 4/8 can be reduced to 1/2. Now, a molecular formula of a compound actually has the number, of each atom present in the molecule. These may not be reduced, but it states the actual number. We'll have a different video on molecular formulas later. But what I want to do is, first of all, show you through a few examples how to actually carry out the steps in determining the empirical formula. I'm not going to read all these to you right now. I'll refer back to those steps as we go through the examples. So, example number 1 wants us to find, it says determine the empirical formula for this brown gas that is found to contain 2.34 grams of nitrogen and 5.34 grams of oxygen. So the first step says that we're supposed to convert grams or possibly percentages of each element into moles using molar mass as a conversion factor. So we'll take 2.34 grams of nitrogen, put that over 1. We'll go to our periodic table and find that the molar mass for nitrogen is 14.007 grams. And remember, by definition, that's how many grams are in 1 mole of nitrogen. We will see grams and grams cancel for nitrogen. We will go to our calculator and find that 2.34 divided by 14.007 is 0.617 moles of nitrogen. Remember, you want to set your calculator, go to mode, float, move that cursor over to 3 and hit enter, so we do not have to record all these decimals we see on the screen. But notice it does say do not round this number. We'll also do the same thing for oxygen, 5.34 grams of O over 1. From the periodic table, I will find that 1 mole of oxygen has 15.999 grams of oxygen. Grams and grams will cancel. 5.34 divided by 15.999 is 0.334 moles of oxygen. Step 2 says that we're supposed to identify the smallest amount of moles and then divide all the other elements then by the smallest amount of moles found. So this is obviously smaller, 0.167, than 0.334. .167 divided by 0.167 is 1, and 0.334 divided by 0.167 is 2. So what we have found here is that it says in number 3, the resulting numbers are the subscripts for each element. Now it did say this should be a whole number, and we did get whole numbers. If not, we'll have to complete then step 4. So we'll talk about step 4 in the next example. But what we have found then is that this gas contains nitrogen and oxygen, where there's 1 nitrogen and 2 oxygens. And this would be then the empirical formula for that gas. Now the second example looks a little different. We see that first of all, they've given us percentages of each element instead of grams. But if you notice back on step 1 over here, it says that we convert grams or percentages of each into moles using molar mass. So we'll just still approach this exactly the same way to find the empirical formula for this substance. Here's the amount of carbon, hydrogen, and fluorine. And we're supposed to find, hey, what is that chemical formula? What's the empirical formula? So we'll take 57.54 grams of carbon over 1. I'm going to go ahead and set up all these. 3.45 grams of hydrogen over 1. And 39.01 grams of fluorine over 1. On the periodic table, we know that 1 mole of carbon is 12.011 grams of carbon. 1 mole of hydrogen is 1.008 grams of hydrogen. And 1 mole of fluorine, sorry, it's not one we use a lot, actually have to go look, 18.998 grams of F. Remember, we'll have grams and all these cancel. So when we do our math, we will be left with moles of each of these. Now you should try this out and do this with me. You'll find that 57.54 divided by 12.011 gives us 4.791 moles of carbon. 3.45 divided by 1.008 will give us 3.423 moles of hydrogen. And the last one, 39.01 divided by 18.998 gives us 2.053 moles of fluorine. Remember, step 2 says that we are supposed to identify the smallest amount of moles, step 2, and then divide all the elements by the smallest amount. It says this should be a whole number. If not, we will complete step 4. And I'm just going to give you fair warning, this one will not be. Okay, it's the reason why we have this example. It says we will multiply them by the lowest whole number factor to get a whole number ratio. You're like, what does that mean? I'll show you. So let's go ahead and divide these first. This is the smallest amount of moles, which will give us a ratio of 1, 2.053, and also 2.053. Now, when we do this on the calculator, let's do the first one here. 4.791 divided by 2.053. I get 2.334, and that is not a whole number. Okay, so we're going to list that as 2.334. The next one, 3.423 divided by 2.053 gives us 1.667. That is not close to a whole number. I cannot round those. So I don't know if you recognize this, but this is basically 2 1/3, and this is 1 2/3. So if we are able to find it says here, step 4, multiply by the lowest whole number factor to get a whole number ratio. If we recognize those decimals as fractions, this is easy. If not, start with the number 2. If I multiply 2.334 times 2, I get 4.668. That's still not a whole number. But if I take 2.334 and multiply it by 3, I get 7.002. That is close enough to be called a whole number, 7. So if I have to multiply this by 3, Step 4 says you must multiply them all by 3, which means 1.667 times 3. I'm going to get 5 here, and this will be 3. And these are all whole number ratios. So what you have found here is that the actual subscripts for the elements are given now in whole number ratios. For carbon, that will be 7. For hydrogen, that will be 5. And for the fluorine, that will be 3. So what does all this mean? Okay, the way that we're going to practice this is actually through a lab. And the title of the lab is, it says determining empirical formulas, but what's kind of cool about this is you are going to be part of his CSI team. It says, I'm going to skip the procedure a second and just go to this paragraph. It says your CSI team, you and your CSI team are called to the scene of a plane crash. The plane shows evidence of a pre-crash explosion. The site of the explosion contains a compound that has this analysis. So it gives us a percentage of every element found in this compound. Now there were people on this plane, and these people are now perished. It says the victims are found in and around the crash and must be identified by the substances found in their belongings or in their bodies, since dental records are not available. Further evidence also reveals that one person was actually murdered with the time of death established 1 hour before the crash. So your goal, your objective here is to use percent composition to identify these substances. So we're going to carry out, using empirical formula, those steps to identify the substances and also answer the investigative questions. What questions? Let's look. Your post lab says, what was the chemical at the crash site? Who was most likely the murder victim? What is the evidence for your answer? Who was most likely the murderer? What is the evidence for your answer? And who most likely blew up the plane? And what is your evidence for this answer? So, who are these people that were on the plane? You have a list here of those that were on the plane. You have a pilot. It gives you some information about the pilot. A pharmacist, a baker. You also have a teacher addicted to sugar-free drinks. You have a pro athlete suspended for drug violations. You have an environmental engineer severely depressed, it says. You also have a suspected drug dealer, and then last but not least, a suspected leader of a terrorist organization, and they are all named. So what you will be doing, and I'm going to do one of them with you just to kind of give you an idea. First of all, the points for your calculations on this lab are huge. There's a lot of work involved in this lab, and you're going to need to show all of your work. So I'm going to show you just one of the calculations. There are several of them that you will do in this lab. This is your data chart for you to complete. You will be identifying the substances found in each of these victims. Here they're numbered. Here you're going to try to identify the body number 1 belongs to what victim do you think off of the list based off of your results. Okay? And so there's a lot of evidence that you may have to evaluate. Where do I get the data from to do all this? This chart. This chart here and here, they do not have to be included in your lab report. This, though, is your data chart to complete. All your calculations you will need to do on a separate sheet of paper. I do not advise trying to type all these things out. You can try, but that's a lot of work to try to do on the computer. You can write all your work out, take photos of them, and embed them insert these images into your lab report. So, for instance, I'm going to do victim number 1. And it says here that victim number 1 had 2 substances found. One of these was found in the blood and briefcase of the substance, A, and the other found in their pockets, B. The percentages are given for substance found in the blood and briefcase, and percentages are given for the substance found in the pockets. I'm just going to do one of these, and I'm going to do A. So I would label victim 1 A. This substance has carbon, hydrogen. Let's skip a line. We've got a little bit of work to put in there. It also contains nitrogen and also oxygen. Just like the examples, we'll take the percentages given, 67.31%, 6.98%, 4.62%, and 21.1%, and we will convert all of those to moles using molar mass of each element. So 67.31 grams of carbon, and we will convert that to moles of carbon using the molar mass of carbon. We will do the same with hydrogen, 6.98 grams of hydrogen over 1. 1 mole of hydrogen will contain 1.008 grams of hydrogen. 4.62 grams of nitrogen will contain, 1 mole of nitrogen will contain 14.00 grams of nitrogen. And then we have 21.1% or grams of oxygen. And we will convert 1 mole of oxygen using the molar mass to find the moles of each of these present. Remember, grams will cancel on all of these. And when we do the math, we end up there then with the amount of moles. So 67.31 divided by 12.011. This gives us 5.604 moles of carbon. 6.98 divided by 1.008. This is 6.925 moles of H. The next one, 4.62 divided by 14.007. 0.330 moles of nitrogen. And the last one, 21.1 divided by 15.999. 1.319 moles of O. Remember, the next step said we're supposed to identify the smallest amount of moles. I believe this would be our smallest amount. So this whole number ratio would be 1. All of the others, 3. All of the others will also be divided by the same value. So the first one for carbon, remember we're looking for a whole number ratio, 5.604 divided by 0.33. We get, it says 16.982, which is really close to that whole number 17. 6.925 divided by 0.33. That's really close to 21. And 1.319 divided by 0.33, that's really close to 4. All those numbers could be rounded to the nearest whole number. So what that tells me then is this substance found on victim 1 in the victim's blood and briefcase has the chemical formula C17H21NO4. And you are supposed to identify what that substance is. And the only way to identify that then is let's compare that to a list of chemical formulas given to you. These are the possible compounds that you will find in the victims or around the victims. And if we look down the middle here and we look for C17H21NO4, we identify that substance to be cocaine. It says it's a narcotic and it is illegal. So we will label here that this is cocaine. You need to check your spelling. The list is right in front of you. We'll box this in so we know that that's the compound that was found in the blood and briefcase. This is A. We'll go to our data chart in your report, or if you're working on just a rough draft of this, for A, we're going to label that cocaine was found here on victim 1. And I would go ahead and write here where it was found. We will identify all these substances, and then based off of the evidence you have here and some of the details given on the passengers and the crew, you should then be able to identify the body with the person and then answer the investigative questions in the post-lab. So remember, if you have any questions, you need to ask your teacher, and have fun with this. It's really fun. Everyone seems to love this lab, but just remember, I know it's a lot of work. You want to make sure that you do include all of your units, you show all of your work. Your calculations are a big part of this grade, but also remember, you are not expected to work on this during the holiday break, during that fall break. So if you want to just do a few in class, do a few today, maybe at least finish victims 1 and 2. When we get back from the fall break, we can pick that up from there and finish out the lab and turn in your report that week. Bye-bye.